I'd like to talk about planar graphs. These are graphs that can be drawn in the plane without any edges crossing. So this, for example, is a planar graph. Here's another graph. And you might think that this graph is not planar, but actually it is planar because there is a way of drawing it in the plane without crossing any edges. See, these two graphs are identical, but there is a way to draw this particular graph in the plane such that no two edges cross. So therefore we say that it is a planar graph. Now it turns out that this graph, this bipartite graph, where we connect every edge on the left to every edge on the right, is not planar. This graph is called K33. So there are 3 vertices on the left, 3 vertices on the right. It's bipartite, and each vertex on the left is connected to every vertex on the right. It turns out this is not planar, and it's sort of difficult. Well, I mean, we'll see how to prove it, but it's difficult to prove it from the mathematical tools that we have now. It's really hard to formally reason about drawing graphs. I mean, you know, if you tried to prove this, you'd probably end up in a mess of cases, and you'd start making claims that are difficult to justify. Try convincing your classmate that this is not planar, but what we're going to do is prove that in fact there is no way for this graph to be drawn in the plane where edges do not cross. So just one bit of terminology, we're familiar with the idea of a vertex having a degree. So the degree of this vertex, for example, is 3, has 3 edges coming out of it. Planar graphs have regions. So they have vertices, they have edges, and then there are regions. For example, here's one region. It's an area of the plane that's completely enclosed by edges. So here's one region. And then there's always the outer region. This is the part of the plane that's sort of outside the entire graph. So for this graph here, it induces 2 regions into the plane, this inner region and the outer region. Let's see. I have some other planar graph. There's a planar graph. Again, there are 2 regions. There's this inner region, and then there's the outer region. Here's an even simpler planar graph, just these 3 vertices and these 2 edges. In this case, there's just one region. It's the outer region. There are no kind of internal regions that are formed from this particular graph. You can have this graph, this hourglass-looking graph. It induces 3 regions. There's the region here, the region here, and then again there's the outer region. So planar graphs are very interesting. They have a lot of applications. We're going to try to avoid looking at trivial planar graphs. So for this class, every planar graph has at least 3 edges. And this is going to imply that for any planar graph, and for any planar graph, and for any region R in that planar graph, the degree of the region is going to be at least 3. What is the degree of a region? Well, for any one particular region, we look at the number of edges that border that region. So for example, this region right here, this inner region here, has degree 3 because it has 1, 2, 3 edges bordering it. In this graph, this inner region here has degree 4 because it has 1, 2, 3, 4 edges that border that particular region. In this simple graph that has 1, 2, 3 edges, there's only one region. Sorry, in this simple graph that has 3 edges, there's only one region, the outer region, and it has degree 3. 1, 2, 3, because there are 3 edges that are bordering the outer region. So this graph up here also only has one region. It's the outer region, and it would have degree 1, 2, 3. So again, the degree of a region is the number of edges that border that region. And so for every planar graph, and for every region in that graph, the degree of the region is going to be at least greater than or equal to 3, because we're going to assume that every planar graph has greater than or equal to 3 edges.